Hello everyone, this video covers sections 3.3 and 3.4 from the book. Before we start, let me just refresh your memory of what we have done so far, or what we did last time. So last time we mainly talked about the product rule and also the quotient rule, which we're going to use over and over. Remember, the product rule is this: if you have a product, the derivative is the derivative of the first one times the second one plus the derivative of the second one times the first one, and you have a quotient, the derivative is f prime, or the derivative of the first one times the second one minus the derivative of the second one times the first one divided by the second one square. Remember that this is not a derivative. So we're going to use this over and over. So I just wanted to refresh your memory on what we did last time, which was this. All right, so now after today, or after you take or after you complete this video, then you should be able to take the derivative of pretty much almost any function. So here it is. The next thing is the derivative of trigonometric functions. So we're going to start with the most basic one, which is sine of x. And if you remember the graph for sine from trigonometry, it looks like this. Okay, well, this was pi, this was 2 pi, 0, the highest point was pi over 2, this was 3 pi over 2, and so forth. Now, the derivative of sine is cosine. So you should just memorize this for now. And if f of x is cosine, then the derivative is not sine, it's actually minus sine of x. Now remember, the graph for cosine look like this. This one starts in here, and it does this, which technically, if you keep going, it will do this. All right, so this is going to be the basis to remember any derivatives of trigonometric functions. The derivative of sine is cosine, or the derivative of cosine is minus sine. Remember that you can also use the notation that the derivative with respect to x of sine is cosine. So it's exactly the same thing. Okay. All right. So now we're gonna use these two plus these rules to find more derivatives. And it is a very good idea to know how to derive them, but I highly recommend you just to memorize them, because you're gonna use it over and over. All right. So now recall that tangent is the same thing as sine over cosine. Therefore, you can look at tangent like if it was a quotient, where this is f and this one is g. Therefore, if we use the quotient rule, the derivative with respect to x of tangent x, remember the quotient rule is this, f over g prime is equals to f prime g minus g prime f over g squared. So the derivative of sine, remember, is cosine times g, which is cosine x. Now the derivative of cosine is minus sine, so this is minus sine, times the derivative, times the first one, which was sine, okay, divided by g, which is cosine squared. All right, so you can see how this formula is giving you this. So this is f, this is g, so this is f prime times g minus g prime times f. On the top, you will get a cosine squared x plus sine squared x divided by cosine squared. But remember, cosine squared plus sine squared is equals to 1. So this is 1 over cosine squared, which is equals to secant squared. Right, let's try one more. Let's say that you want to find what the derivative with respect to x now of secant. Remember, secant is the same thing as 1 over cosine. So if we use the quotient rule again, this will be equals to the derivative of the first one is 0, so times cosine x will still give you 0, minus the derivative of cosine, which is minus sine, times 1 divided by cosine square. And this is the reason why you had to take a trigonometry to simplify these things. So this is the same thing as sine x divided by cosine square. But cosine square, you can rewrite it like this. And notice that sine over cosine is tangent, and 1 over cosine is secant. So therefore, the derivative of secant is tangent secant. It is a very good idea to know how to derive it, but more important is just memorize this. You're going to use this thousands of times. So the derivative of this is this. So this is what we have so far. The derivative with respect to x of sine is cosine of x. The derivative with respect to x of cosine is minus sine. The derivative with respect to x of tangent is secant square. Again, you should memorize this. We also did this one. The derivative with respect to x of secant was equals to secant x tangent x, and there is only 2 missing, which I believe the homework will ask you to derive them, but here they are. The derivative of cotangent x is minus cosecant square x, and then finally the derivative with respect to x of cosecant is minus cosecant x cotangent x. Now, an easy way to remember which one is which, notice that all the ones that are the derivative and the function starts with c, the answer is negative. Derivative cosine is negative, derivative cotangent is negative, and derivative of cosecant is also negative. So that's one way to remember. Now, I highly recommend you to memorize all of them because you're going to use it over and over. Alright, so memorize this. Alright, now, so let's combine this with the product and the quotient rules now. So let's say you have this function. Let's say that h of x is equals to x cubed times tangent x. And you want to find the derivative. So therefore h prime is going to be equals to the derivative of the first one, remember, times the second one, because this is a product where this is f and this is g, plus the derivative of the second one times the first one, which is this. Now the derivative of x cubed from before should be 3x squared. This is times tangent x plus the derivative of tangent, remember, is secant square. So it will be secant square x times x cubed. And in this case, you can factor the x squared. It is not necessary unless it's asking you to do that. Otherwise, you can leave the answer here. But in this case, it will be x squared times 3 plus x times secant square x. All right, let's try a few more. Let's try this example now. Let's say that h of x is equals to the square root of x times secant x. Okay, so now this one is f, this one is g. So then h prime will be the derivative of the first one times the second one plus the derivative of the second one times the first one. Now remember the derivative of x squared, we have done that now multiple times. It's just 1 over 2 radical x times the second one plus the derivative of secant, which is secant tangent. So this will be secant tangent times radical x. And that's it. Okay, now let's try one where we have to use the quotient rule. So let's say that h of x is equals to x squared plus 1 divided by x plus sine. All right, so now in this case, this one is f, and this will be g. All right, so therefore from here, h prime is going to be the derivative of the first one, which will be 2x times the second one, which will be sine x, minus the derivative of the second one, which is 1 plus cosine x times the first one, which is x squared plus 1, everything divided by x plus sine x squared. And then simplify the top if possible. If not, you can just leave it like that. All right, let's try a few more. Let's do one that is actually a little easier to handle. Let's say that this one was cotangent x divided by e to the x. So therefore from here we will have the h prime, the derivative of cotangent, remember, is minus cosecant squared, so it will be minus cosecant squared x times e to the x, and then minus the derivative of the bottom, which is e to the x, times the top, which is cotangent x, and everything divided by e to the x squared. In this case, you can factor on the top e to the x, and actually even minus e to the x, and this will be cosecant squared x plus cotangent x, and on the bottom you have e to the x times e to the x. So you can cancel this, and the answer will be minus cosecant squared x plus cotangent x divided by e to the x, and that's it. All right, so by now these are the rules that you know when it comes to derivatives. This is pretty much what you know already. You already know that the derivative of this should be this. You also know the product rule. You also know the quotient rule. And now you need the trig derivatives, which this one can use any of these two. Okay. There is one more rule which we'll learn in section 3.4, and after that, once you have the next rule, which you can call it rule 5. So with those 5 rules, you can take the derivative of any function. So that's what we will do in the next section. All right, section 2.4 is one of the most powerful things to take derivatives, but it relies also in the product rule and the quotient rule and so forth. And this is technically related to the composition of functions. So if you remember from way back on the day, so the composition of functions, okay, so recall this it's actually from algebra. You have f composition g of x, This is the same thing as f of g of x. Okay? So we're gonna call this h of x. Okay? So what the chain rule says that is this: you have a composition of functions, which will be this. So if you have a composition of functions, then the derivative, so this is the short notation, is the same thing as the derivative f evaluated at the function g times g prime. Or in the long notation, you say the derivative of h with respect to x, it will be the derivative with respect to x of f evaluated at g of x. So this part is very important, evaluated at this part, times the derivative with respect to x of g. Alright, so this one is easier to I mean, both of them are the same. This one just looks nicer than this one, but this and this is exactly the same thing. Alright, so let me show you an example on why the chain rule is such a big deal. Let's say that you have h of x is equals to 5x plus 2 to the 4th power. Okay. So therefore here you have two functions, 5x plus 2, which is the g, and the 4th power, which will be f. Okay. So therefore, if you only have this, well, let's say you have the function was like this, just if f of x was equals just to x to the 4, then the derivative will be just 4x cubed, and that will be the end of the story. And that's technically what we're going to do here. So let me do this slowly. All right, so here we have h prime is going to be 4 5x plus 2 to the 3rd power, which is related to this part here, because the derivative of this is equals to this. So just think of all of this as being just one variable by itself, and then times the derivative with respect to x of the inside. That's the easiest way to think about it. So then it will be 4 times 5x plus 2 cubed times the derivative inside, which is just 5. And therefore this will give you 20 times 5x plus 2 cubed. That's it. Now, if the chain rule didn't exist, then you could use the product rule, but because this is to the 4th power, you have to do the product rule 4 times. And that will take you a long time. And once you simplify, you will still end up with this. So for these questions, the chain rule is way faster than the product rule. Now on the exam and in the practice test, you have a function that looks like this, like the square root of 2x plus 5. And you had to find the derivative the long way, but now with the chain rule, you can do it pretty fast. Here, f of x is equals to the square root of x. Remember that the derivative of this was 1 over 2 y equal x. Or this was 1/2 x to the negative 1/2. Alright, so therefore, h prime is going to be 1/2 2x plus 5 to the negative 1/2, which represents this part. So we're still doing this. The extra part is that now you have to take the derivative of whatever is inside. So times the derivative with respect to x of the inside. Well, what is the inside? This time is just 2. So it will be 1/2 times 2x plus 5 to the negative 1/2 times 2. So this just gives you this part. And in this particular case, this will cancel this one. So this simplifies to just add 2x plus 5 to the negative 1/2, which, if you remember, this is 1 over the square root of 2x plus 5, even though this is completely right. All right, so now let's do one where you had to use sine and cosine. So let's say we have this h of x is equals to tangent x to the 6th power. Okay, so here the function f of x will be x to the 6th. And remember, the derivative of this is 6x to the 5th. So therefore h prime is going to be 6, whatever is the function g. So in this case, g of x is equals to tangent x. So times the derivative with respect to x of tangent. And this one should be a 5. Okay, so always look to this part. All right. Okay, so then from here, this would be 6 times, okay, so this is 6 times tangent x to the 5th power times the derivative of tangent, which I told you is secant squared x. And that's it. That will be the answer. All right, let's try one more with trigonometry. Let's say that h of x is equals to sine x minus cosine x to the 3/2. Okay? So therefore h prime is going to be 3/2 times sine x minus cosine x, and then on the top is going to be 3/2 minus 1 times the derivative with respect to x of sine x minus cosine x. All right, in this case, f is equals to x to the 3/2, and g is the inside. Okay. All right, so therefore, if we simplify, we end up with 3/2 sine x minus cosine x to the 1/2, because 3/2 minus 1 is equals to 1/2, times the derivative of sine, which is cosine, and the derivative of cosine, remember, is minus sine, so minus and minus becomes plus, and it's plus sine x. And that's it. Okay, so this gives you this. The derivative of this is this. Here the derivative of this is this part, and so forth. All right, the process from now on is the same. You just got to be careful on what function you have. The next examples, or the last examples, you're technically gonna have to use multiple rules to do the derivative, so you have to do it pretty slowly. So let's say the function we have is this. Let's say the h of x is equals to x cubed times sine of x to the 4. All right, so here we have f, and this is g, so this is a product. So first you have to use the product rule, and then since this is a composition of two functions, you're going to have to use the chain rule for this part. Okay, so therefore here this is what we have. H prime is going to be the derivative of the first one times the second one, okay, plus the derivative of the second one times the first one. Now the derivative of the first part is easy. The derivative of x cubed, remember, is just 3x squared, then times sine x to the 4. Now this is the part where you need the chain rule. okay? And we can even do that on the side. So here we have sine x to the 4. In this particular case, f is just sine of x, and g is equals to x to the 4. So remember, the derivative of sine is cosine times the derivative of the inside, which is 4x cubed. Okay, so this is the chain of rule. So therefore, the derivative of the second part, which will be this, is this part right here. This will be plus 4x cubed cosine of x to the 4, okay, so this times x cubed. So you simplify a little bit more, this will be 3x squared sine x to the 4 plus 4x to the 6 cosine x to the 4, and that's it. Right, let's try a couple more. So let's say now that h of x is equals to tangent x to the 4 power times sine of 2x plus 1. Okay. All right, so clearly this is a product, so you have to use the product rule. So therefore h prime is going to be the derivative with respect to x of the first one, okay, times the second one plus the derivative with respect to x of the second one times the first one. Okay. All right, so then the derivative of this respect to x using the chain of rule is going to be 4. So it will be 4 tangent q of x times 1, because the derivative of x equals to 1, then times the second one, so nothing happens to the second one there, plus the derivative of the second one. So this is a composition of functions, so you have to use the chain rule. So the derivative of sine, remember, is cosine times the derivative of the inside. The derivative of this is 2, so times 2, and then times the second one, which is tangent x to the 4 power. Then just simplify. So this gives you 4 tangent q of x times sine of 2x plus 1, then plus 2 tangent x to the 4 power times cosine of 2x plus 1. Okay, so notice that this is the same thing as this, okay? So it just depends how you want to write it. All right, so now that this kind of makes sense, let's get a little crazy and do one that it has 3 functions. So this is what I mean. Let's say that h of x is equals to sine of x cubed plus 1, all of this to the 4 power, okay? Actually, let me change that to the 10 power. So technically here you have 3 functions. You have x to the 10, you also have sine, and you also have x cubed plus 1. So you have a combination of 3, or a composition of 3 functions, okay? So let's do this slowly. So h prime is going to be 10 times sine of x cubed plus 1 to the 9 power, okay? This is actually 10. actually the 10 power. So the derivative of this one, remember, is 10x to the 9. So that's why we got this part, 10x to the 9. Now times the derivative with respect to x of sine of x cubed plus 1, which itself is a composition of two functions. So this is what we have so far. You have 10 sine x cubed plus 1, the whole thing to the 9 power, times the derivative of sine, which remember is cosine of x cubed plus 1, times the derivative with respect to x on the inside, which is now x cubed plus 1. Alright, so therefore the last thing will be 10 times sine of x cubed plus 1 to the 9 power times cosine of x cubed plus 1 times the derivative of x cubed, which is 3x squared, and the derivative of 1 is 0. And that's pretty much it. And then you can just simplify everything. So this will give you 30x squared times cosine of x cubed plus 1 times sine of x cubed plus 1 to the 9 power. And that. Now finally, we can have more features now for the famous e to the x. So remember that you have e to the x and you take the derivative, it was just e to the x, okay? But now we have a extra tool using the chain rule. So for example, and you're gonna use this also hundreds, if not thousands of times. Let's say that h of x is now equals to e to the 4x. Then the derivative is going to be e to the 4x. So you just rewrite the function times the derivative with respect to x or the exponent, which in this case is 4x. So therefore this will be e to the 4x times 4, or just 4 e to the 4x. So in general, if you have e to the kx, the derivative is going to be k e to the kx. Okay, so you should also memorize this and do not confuse that with the product rule. One of the biggest sins, so this is a sin in math, is to do this. If you have e to the 4x and you find the derivative, people do this, they say this is 4 e to the 3x, and this is a crime. You cannot do that. I mean, you can, but it's wrong. All right, so now let's try one more with this. Let's say that h of x is equals to e now to the x cubed. So the derivative will be e to the x cubed. So you just rewrite whatever you have times derivative with respect to x of the exponent, which in this case is x cubed. So therefore this will be e to the x cubed times 3x squared. So therefore this is 3x squared e to the x cubed, right? And it could be technically any function you want. So finally, let's say that h to the x is equals to e to the secant x. So therefore h prime will be e to the secant x times the derivative of secant. But remember, the derivative of secant is secant tangent. So therefore h prime will be e to the secant x times secant x tangent x. And that's it. All right. So once you know how to use the product rule, the quotient rule, and the chain rule. Now you can take the derivative of any function. You just have to practice the rules and be careful to follow the rules. And I highly recommend you to do something like this. Notice how you say this goes here times the derivative of this. So don't try to do the whole thing at once. So do everything step by step. Then your life will be pretty simple. All right, so that's it for section 3.3 and 3.4.